Assalamualaikum warahmatullahi wabarakatuh. My name is Ridhuan bin Samsul, ID number TB00220004. Will be presenting project assignment for BTE1212 Electrical Fundamental Laboratory. So in this project, the task is to draw half wave and full wave rectifier by using Mutisim software. This is the example of half wave rectifier, and this is the example of full wave rectifier given by this slide. So now we're gonna go into Mutisim and I'm gonna show you the circuit that I built. So we have two circuits here. The one on top is for half wave rectifier circuit, and the one in bottom is full wave rectifier circuit. So in this circuit, I'll be using AC voltage source with 120 VRMS and 60 Hz frequency, one diode for both. The difference between a half wave and full wave rectifier is the number of diode itself. The half wave rectifier has only one diode, while the full wave we have connected 4 diodes, and we also have tectonic oscilloscope. We will connect it to the load, which is 1 kilo ohm resistor. So we're gonna run. We're gonna see the result in the oscilloscope. So this is the frequency. This is the waveform that we get from the reading to the 1 kilo ohm resistor. So as you can see, the waveform goes up in the positive side of the, and then it goes down, but not completely down like the basic AC voltage. That is because the signal is now flowing to only one direction, which is up, and it doesn't flow back, which is what we see here, with no readings at the bottom of the wave, which is the wave now goes up and down, which means technically this is a DC signal that we seeing right now. So for the measurement that we get from this waveform, we get that the frequency is 60 Hz and the period is around 16.6 milliseconds. The voltage peak to peak is 168, and the maximum voltage is 168 volts, which means that the voltage peak at 160 volts to 0, go back to 0 and peak again at 160 volts. Now we're gonna see what happened if we change the resistor to a capacitor. I just choose 0.10. Let's see. So as you can see from the wavepoint, the voltage peak and then it drops down slowly, and then it peaks again, and then it drops slowly, which different from before. We see the waveform peaks and then drops to zero, and then peaks again and drop to zero, but this time it peaks but drops slowly because the capacitor is in this point, like this peak point is charging, and then it drops slowly, meaning that it is discharging slowly. It slowly lose the power that it store. That's why it doesn't drop full down to zero, because it takes time for it to go down to zero, and then we can see it go up again, peaks again. So this is for 0.10 p farad. We're gonna see what happens if we increase a bit the value of this capacitor. Let's just say 1. So as you can see, you can't see, but there is peak here, and then the capacitors drops the voltage value drops so slow, and then it peaks again. It almost looked like it was a straight line here, but actually the voltage in this capacitor peak but drops slowly, and it peaks again, drops slowly. So basically means that the value of capacitor will heavily influence this voltage drop. If we use a bigger capacitor, we're gonna see much less of a voltage drop here. So let's go to the full wave rectifier. So by default we use 1 kilo ohm resistor first, and we're gonna observe the wave form generated. So as we can see, the waveform is different from the one that we see from half wave rectifier. In one wave rectifier, we see that the waveform is basically like this. It peaks and it turns down to zero for some times, and then it peaks to maximum voltage again, and then it turns down to zero at some times here. But in this full rectifier circuit, we don't see that zero for that much time. We see here that the voltage peak and turns to zero and immediately peaks back again. So let's just put down some measurement here. So as we can see, we can observe the difference of the measurement from the half wave and full wave rectifier. So in half wave rectifier, we got the frequency for in this load is 60 Hz, but in the full wave rectifier, we got an up to 120 Hz of frequency, while the period itself from half wave rectifier is 16.6. We got at the full wave rectifier, we got like 8.33 milliseconds, which is far more faster. And let's try the load. Let's change the load to a capacitor. And we observe what happens to the waveform. So at the waypoint, at the waveform, same as before, we see the voltage spike and then it drops slowly. Spikes again and then it drops slowly. And we test it out with bigger value of capacitor. Just see one. And now we see the waveform. We see there is a peak here, and the voltage value drops so low that it basically like stay at the peak value, unlike the before 0.1 pF. This one drops very low and then it peaks again and drops very low and then it peaks again. So I think I cover all of it. The difference between half wave and full wave rectifier, what happens to the waveform when we connect different kinds of load, and yeah, that's it. Thank you for watching.